For thousands of years, fire was humanity's only way to harness energy. But did you know that as early as 500 BC, the Chinese were already transporting natural gas through bamboo pipelines? They used it to boil water and cook food, long before the world even understood what natural gas really was. Fast forward to today, and this same invisible fuel powers entire cities, industries, and homes. But how does it get from deep underground to your stove or power plant? Most people never think about the complex network of drilling sites, pipelines, and processing facilities that make this possible. And here's the challenge. Natural gas is useless unless it's extracted, refined, and safely transported. That's exactly what we're about to break down, step by step, from its hidden origins beneath the earth to the moment it fuels your daily life. Deep beneath the Earth's surface, vast reservoirs of natural gas have been trapped for millions of years. But extracting this energy source isn't as simple as just drilling a hole. If done incorrectly, gas can escape, leading to safety risks and environmental damage. That's why modern extraction methods have evolved to make the process safer and more efficient. There are two primary ways to access natural gas: conventional drilling and hydraulic fracturing, or fracking. In conventional drilling, gas flows freely from underground pockets into wells. But when gas is trapped in dense rock formations, fracking is used, pumping water, sand, and chemicals at high pressure to release it. This method has revolutionized the industry, unlocking resources once thought unreachable. However, raw natural gas isn't ready for use right away. It often contains water, carbon dioxide, and even toxic hydrogen sulfide. If left untreated, it could corrode pipelines, reduce efficiency, and pose health risks. That's why gas is sent to processing plants, where impurities are removed and valuable byproducts like propane and butane are extracted. With the gas now purified, the next challenge begins. How do we move it safely across vast distances to where it's needed? Purified and ready for use, natural gas now faces its biggest challenge: distance. Unlike oil, which can be easily stored and shipped, gas is highly pressurized and must travel through a vast interconnected network to reach consumers. If transportation isn't handled correctly, leaks, pressure drops, and supply disruptions can occur. The most common way to move natural gas is through high-pressure pipelines, stretching thousands of miles across continents. Compressor stations keep the gas moving by increasing pressure along the way, preventing slowdowns and losses. However, pipelines have limitations. They can't cross oceans. That's where liquefied natural gas, or LNG, comes in. By cooling natural gas to minus 162 degrees Celsius, it becomes a liquid, shrinking in volume by 600 times. This makes it possible to transport massive quantities by specialized tankers to regions without pipeline infrastructure. But LNG transportation requires complex facilities and strict safety measures. A single leak could result in catastrophic explosions. From pipelines snaking beneath cities to LNG tankers crossing oceans, transportation is the invisible backbone of the natural gas supply chain. But even after traveling thousands of miles, gas still isn't ready to be used. It must first be distributed safely to homes and businesses. After traveling across vast distances, natural gas still isn't ready for direct use. It must first be distributed through a carefully controlled network. But here's the challenge. Gas leaves high-pressure pipelines at speeds too dangerous for homes and businesses. If not properly regulated, it could cause leaks, explosions, or equipment failures. To prevent this, natural gas enters local distribution networks, where pressure is gradually reduced at regulator stations. From here, it moves through underground pipelines toward homes, factories, and power plants. But even at this stage, safety is critical. Specialized sensors and automated shutoff valves constantly monitor the flow, detecting leaks before they become disasters. Once inside your home, natural gas reaches your appliances through smaller pipes. But even then, you might wonder, why doesn't it have a smell? The answer: natural gas is odorless. To make leaks easier to detect, companies add a chemical called mercaptan, which gives it that distinct rotten egg smell. From deep underground to your stove, natural gas has traveled through a complex, carefully managed system. But this network isn't perfect, and as the world changes, the industry must adapt to new challenges and solutions. For all its convenience, natural gas comes with major challenges, some of which could shape its future. One of the biggest concerns? Methane leaks. While natural gas burns cleaner than coal, methane, its main component, is a greenhouse gas 80 times more potent than carbon dioxide in the short term. Even small leaks along pipelines can have a massive environmental impact. Another issue is energy dependence. Many countries rely on imported gas, leaving them vulnerable to price spikes and supply disruptions. The 2022 energy crisis in Europe, triggered by reduced Russian gas exports, exposed just how fragile the global gas network can be. This has forced governments to rethink their energy strategies, looking for more secure and sustainable alternatives. So what's the future of natural gas? One promising solution is blending hydrogen with natural gas, reducing emissions while using existing infrastructure. Another innovation is carbon capture and storage, which traps carbon dioxide before it enters the atmosphere. The industry is at a crossroads: adapt and innovate, or risk being replaced by cleaner alternatives. But one thing is clear: natural gas will continue to be a key player in the global energy mix for years to come. From ancient bamboo pipelines to modern LNG tankers, natural gas has come a long way. Today, it moves through an intricate global network, powering homes, industries, and economies. But while it remains one of the world's most important energy sources, its future is uncertain. Methane leaks, geopolitical tensions, and the push for cleaner alternatives are reshaping how we extract, transport, and use natural gas. So what happens next? Will innovations like hydrogen blending and carbon capture help gas stay relevant in a low-carbon future? Or will renewables and batteries slowly replace it? What do you think? Is natural gas a bridge to cleaner energy or a fading fossil fuel? Let me know in the comments. And if you found this breakdown insightful, hit like and subscribe for more deep dives into the world of energy and infrastructure.